Screen is not shared, sir.
Oh, again, some issue with that. I'll share it again. Oh, it's not shared at all. Is that okay? Can you see it?
Yes, sir.
Okay, good. I'll show you again. Okay. I'll close this. Okay. Start. If you're working on part design, okay. Just get into part design. Okay. So in first class, I showed you how to insert this. Okay. Access system. And then we discussed about a few parts. We already created 3D model. Okay. Now again, let's have a look at this. How to rename it? Always get into this properties, product, and rename it here. Okay. You have to give part number, revision, definition, nomenclature. Okay. Okay. Now, for example, let's let's have a look at this. How this is going to first. Nothing is highlighted. Okay. Only this will be highlighted. Okay. And one more option which is important for you to keep the toolbars default. Okay. If the toolbars are scattered, okay, then you need to right click on the toolbar. So here also you can right click here. All these are toolbars. Okay. You have to just right click and then say customize. Okay. So then go to toolbars, say restore all contents, restore position. Okay. So all your toolbars will be in position. Okay. Then you close it. Okay. Today let's have a look at this. So always we need to use position sketch only. Okay. Please use position sketch. You will have control over the origin as well as the orientation of the part. Okay. And then so which face you have to select, which plane you have to select, it depends on the part to be designed and how the part is going to be assembled in the assembly, and that all those things, based on those things you have to select. As of now, let's select default one. So this is, and how to select, by default if you want to select it. So have a look here. Okay. This is this is ISO view. Okay. Can you see it here? Okay. So please have a look at this. This is isometric view. This is front view. Okay. Back view, left view, right view. Okay. All the views are available here. So which view you want? Okay. For example, if you want front view, click on this front view. Okay. And this will show front view. Okay. This is default. By default, this is the front view. Okay. So let us select this. As I mentioned, so this is the default access system. So as of now, do not change anything, because based on the regulations or based on the requirements of the company, we are going to change the things here. Okay. That's the reason we keep as it is, and now you are in the sketcher. Okay. So this is the sketcher workbench, and you can see different toolbars here. Okay, this is the one which you are going to use to create the sketch. Okay, profile. Okay, you can see all the shapes of this. Okay, profile again. How to use them? Let us see. For example, I want to, and one more important thing is when you are creating a 3D model, what is the expectation of? This is one of the important points that you need to follow the design procedure, design for manufacturing procedure. Okay. For example, if I want to design a bracket, then what is the manufacturing process of that? So you take a sheet of that, okay, a flat sheet, and then you are going for a bending, okay, bending activity. So that is simple example. For example, this is a sheet. So take a sheet first, okay. So let us think. This is a, what is the rule when you create a sketcher? It's not constrained, okay. We need to constrain it, okay. So how to constrain it? Use the dimensions here, okay. Horizontal one, okay. Let's say this is 60, okay. From here to here, let's say this is 120. Okay. This is 8. From here to here, this is 102. Okay. So as I mentioned, always you need to give dimensions, 2 dimensions from this axis system. Okay. For horizontal, I have taken a dimension from this to this. Okay. And for vertical, one vertical line, I have taken dimension from this vertical axis to this. And then remaining vertical lines will be dimension will be done from this already initially controlled one. Okay, this is already fixed one or controlled one, and this will be done in this way. So why what it is done later? If you want to modify it, it will be very easy for you to modify, or some other guy, some other design engineer, you designed it and you are busy with some other work. Then if some other guy want to design it, then it will be easy for them. Okay, so always follow this, and then come out of this. Once you come out of this, then define in work. Okay, right click on this part body and say define in work object. Okay, and this will be, now you are at this stage. Okay, the body will be created under the part body. Okay, so now we are going to pad definition. Okay, pad definition. Okay, so how much thickness you want? So let's say some 20 thickness is there. Okay, or let's say 30 thickness. Okay, I think it's still not okay. Let's make it. Okay, okay. So this is my say, for example, this is my sheet. Okay, so you cannot expect sheet thickness more than 2 or 3 but we cannot say this as sheet. But this is the first step of creating a bracket. Okay, so how we have to do that, let us see. Okay, so let's assume that this is the outer surface of the bracket. Okay, and this is the inner surface. This is going to be inner surface of the bracket. Okay, so now we are going for bending. Okay, for example, we want bending both sides. Okay, uh, and the radius will be outer radius will be some around 10 millimeters, you can say. Okay, then how to create the radius? Okay, here it is. Okay, edge fillet. You have to use edge fillet. Okay, click on this edge fillet and then select the edge. Okay, this edge. Okay, and now what is the radius you want to give? It is 10, for example. Okay, so both sides have given radius. Okay, now please remember this operation. Okay, shell operation. Okay, click on this. So how much thickness is required? What is the thickness of your part? Okay, if it is 2 mm or 3 mm, let us say 3 mm. Okay, 3 mm. Default outer thickness, outside thickness, keep it 0. Okay, faces to remove. Okay, what are faces you need to remove? Okay, because you don't know the shape of the part. Okay, when you have some a design with you, I mean a drawing which is already created, either they will ask you, they will provide you a drawing. Okay, there are different types of uh, projects, like sometimes you have to create a new 3D models from already existing old drawings. Okay, that is sometimes you will be working on such kind of projects, or you have to, sometimes 3D models are already available, which are dumb models. Dumb in the sense you can't have history of the solids. Okay, so you only can look view them, you cannot modify them. In case if you want to modify them, you need to create a history like this. Okay, unless you have a history like this, you cannot modify it. So that's kind of another projects, like sometimes OEMs send you saying that all these are dumb models and I want them to convert them into models which are with history. Okay, then you have to start creating 3D models using the drawings. Okay, or with the existing model also they will send you. I'll show you how to do that. Okay, so shell, now coming to shell operation. Okay, faces to remove, just select the faces. I'm selecting two faces here. Okay, and also this face will be removed. Okay, say okay. Okay, this is my bracket. So roughly we have done something. Okay, so change the color, just get in here and then change it here. Okay, so this is how the bracket kind of parts are generated in 3D model, and this is the operation used. Okay, shell operation. Okay, any questions in this? Very simple operation. I'll provide you going forward, once you all if you install the Catia, then I'll provide you few small drawings. Okay, then as of now, please have a look at this, what I'm creating and how I'm creating, and then you start practicing at home, and it is not very difficult. Okay, it's very easy, you can do that. Okay, so I want to have a hole in this. How to do that? I want to have a hole in this. So always the best practice is to select the face, not the surface, not this face. Okay, always select the plane which is parallel to this. Okay, so I want something on this surface. Okay, so this plane is far away from this surface. How far is it? It's around 47 mm away from this. Okay, okay, either you can create a plane here. Okay, or directly you can see there is a plane. Okay, so how to create a plane? Okay, this is how we need to create a plane. When you need to create one hole on this surface. Okay, so there are so many options in this. Okay, this is very important. Okay, please remember how to create a plane. Okay, so what is the reference surface? This is the parallel surface. Okay, and I want to create a plane at 47 mm away. Okay, say preview. The plane is created. This is your plane. Okay, select the plane. So I'm considering all default. Okay, I'm not changing anything. Okay, so now tell me what is the, and here while creating holes, when you are creating a circle, okay, then always remember that you should not click directly. So if you click directly here, it will coincide with the center of this part. Okay, this is the center of this part, so it will coincide, but that's not the right way of generating a hole. Okay, always when you are creating it, so please click it outside and generate a circle outside, and then what is the diameter of hole you want. Okay, for example 30 mm hole I want, then just say 30 mm. Okay, and then now take this dimension, select the center of this hole, and then this axis, center of this point. Okay, and say coincide. Now it is coincided. Okay, this is the right method of creating a circle or a hole. Okay, please remember this. Okay, now we are coming out of it. Look at this geometrical set. Okay, whatever sketches or whatever things you have created will come under this geometrical set. Okay, even this sketch you can move it to the geometrical set. Okay, you can click on that. Okay, remember this process also. If the things are here, like inside this, there will be one inside the pad. Whatever you have selected the sketch, that will appear inside the pad. Okay, inside the body. But if it is in the same tree, if it is coming under this tree, then it should be moved to the geometrical set. Okay, so we need to have a very clean history tree. Okay, so you need to maintain a very clean history tree, so that the person who works in future also can easily understand and should be able to modify it. Okay, so now coming to this hole, how to do that? Select this sketch again. Okay, now you can give just 10 mm or just 5 mm. Okay, it's taking in the reverse direction. So either you can click on the arrow, red arrow showed here to change the direction, okay? Or you can say reverse direction. So, reverse direction. It will change the direction of the hole, okay? Which side the material should be removed, okay? So now the material is removed. Have you understood why it was asking? Because direction was in opposite side. So the sketch is created here on this face, and the direction of material removal is material is available this side, right side, but it is removing the other side, material where material is not available. That's the reason. If you see now, if you click on that, this will say the operation is performed on the feature is unnecessary because there is no material to remove and you are performing this operation. So that is what it is saying, okay? And now you have to change the direction so that now the material is on right side. So now the hole is going to remove the material. The material is removed, okay? This is how we have to create a hole in the bracket, okay? And now when you create a bracket like this, then immediately you have to rename it, okay? Part body, and also you can rename these features, okay? For everything you can rename based on the requirement. Some for some projects they don't ask you to rename, okay? You have to name it, okay? If pad 1 is okay for them, then it's okay, but we should know where we have to rename it, okay? And also graphic, what is the color they are expecting, okay? And the other things mostly we are not going to change, okay? Points and color and all these lines and curves we're not going to change. Mostly the color of the part, okay, if required, okay, we have to change. Okay. Say apply and just leave it. Okay, then to have clean view, let's hide the geometrical set and also hide the system if required. Going to completely hide. From inside you can hide it. Let's keep this so that we can understand. So now I want front view. This is the front view. Okay. What is this? ISO view. So all different views you can get from here. Okay. Okay. So after generating this, what is next step? So I want to generate a drawing out of this. Okay. Again, start mechanical design. Now graphic. Okay. I want a white sheet. Okay. Of A3 size. Okay. ISO standard. Okay. 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 Now I'm going to create this. See, this is the front view. Okay. Always you need to select front view first. Okay, front view. Go back to part. And always you need to select a plane. This is the plane. Okay. This is the plane. ZX plane I'm selecting. So this is my front view. Okay. Front. Okay. So to generate this, okay, to create a 3D model, as I said, this is engineering language. Okay, drawing is nothing but engineering language, or we communicate with the plant people. So whatever you design, all the drawings will go to plant, and they are going to manufacture it. Okay, so the plant people should know what are the dimensions and size and shape of this part, and how to, what is the material used. Okay, all these details will be there. I'll show you in next class. I'll show you a sample drawing where all this information will be available in the drawing. Okay, now how many views are required to show the complete details of this part? That's very important. Okay, so that is what we are communicating with the plant people, that this is the part I have designed, and this is the thickness of the part, this is the material I used, and you have to use this material to create this part. Okay, and how many views are required? So in front view is always a view where you get maximum details. Okay, here maximum details in the sense you are going to get the shape of this the complete sheet dimensions here, as well as the diameter of the circle. Okay, okay, let's see how to generate it. Okay, so this is my weight, parts weight. Okay, height of the part 180, 120. Okay, now what is the position of pole? So this is the position of pole. Okay, from this end.
Sir, this is front view or top view, sir?
Sorry, this is front view.
Front view.
Yeah, you can see here. Yeah, this is front view of scale 1:1. Okay, and here one more thing is important. When you just start working on these things, I'll explain you step by step. Okay, everything at a time, you'll get confused. So we need to define the datums also. What is the datum? Okay, based on the, please remember these things. Okay, they are very important. Datums are datum is defined for every part. Okay, datum is the surface from which it's a theoretically they we assume that theoretically that surface is perfect. Okay, and which surface is perfect? This will be, for example, this bracket is going to be welded on another part. Okay, for example, we are going to this part, this part, this face will be welded to another part here. Okay, for example, roughly I'm just I'm telling you, just for example. Okay, for example, let's say one more part is coming here. Okay, so some more part is coming, which is okay, not constraining it, I'm not doing it. Okay, just for, let's see, this is the, let's say, okay, so this is another part where it will be welded onto this surface. Okay, so it is assumed that this surface is perfectly flat. Okay, and this, even the surface roughness is there will be some expectation on this roughness also, surface roughness. Okay, you need to maintain that surface roughness. Okay, and also this part is also flat, assuming that this part is also flat, and the surface roughness of both will be controlled. Okay, as per the dimensions or as per the requirement given by our customer. Okay, and that's the reason we consider this phase as datum A. Okay, so datum A in the sense this is the completely um, theoretically correct surface. Okay, perfect surface. So when you have a hole, then because on this surface there is a hole, so sometimes they consider this as datum. Okay, this axis, always consider axis as datum A. Okay, okay, how to show that? Okay, this is the dia. Okay, diameter, okay, T dia. Let's delete this. Okay, and datum will be placed like this. The datum is placed like this. Okay, there will be symbol. We need to add this dia symbol here. Okay, that we have in this, we'll add that also. Okay, that will add. Okay, now see, this is the dia, and this means this axis of this hole is considered as datum A. Okay, so we are going to give dimension from here to this surface, and from this surface is defined. Okay, and then let's define this surface. Okay, and then this to this it is already defined. Okay, so all the dimensions are defined here. With these dimensions you can create a flat. Initially I have created one block, right? So with these dimensions you can create a block like this. Now what is the information missing in this? Okay, we can see only a flat surface of dimensions. Okay, we are going to take a width, a dimension of this much width, and then and height of this much. Okay, and then we have a hole of this much, and we don't know how much what is the depth of the hole. Okay, here we cannot see the depth of the hole, and also we cannot see the depth of the part. Okay, how much is projected towards backward or forward. It's not forward definitely, because we cannot see any dark line here, so this is definitely not the only. These dark lines are considered. Okay, so here this is thin line. Have you observed thin line? This line is because of the fillet what we have given. Okay, so here only that much information is available. Now what is required for us? We need to understand how much is the thickness of the part. Okay, to understand that thickness of the part. Okay, so what we need to do, we need to take, this is your second step. Okay, so let's update it. When this is the update symbol, when you see here update symbol, please click on that. Okay, or else directly you can right click on this and say update. Okay, oh, that's the reason, as we have created this one, so that's the reason it is asking update. Okay, let's delete this. Whenever you do some changes in the 3D model, it's going to ask update. Okay, see that block is also projected here, generated here. Okay, so I'm again going to update it. Now the block is disappeared. Okay, and this dimension disconnected, got disconnected. So you can give it again. Okay, surface, it should be black in color. Okay, so now what is the missing information we want? How can we get it? So this is the second step. Okay, always this is your first step, creating front view. Always select this and then get into this part and select the surface. Always you need to select the surface. Okay, if you are deciding to how you decided to take this, so maximum details you should show in the front view. Okay, if it is a front view, then you have to select this one. The side view, if you want to show side view, then you have to select this surface. Okay, this plane. Okay, so after generating that, again the second step is go
एनआरआई है तो नहीं बोलना और सीट के लिए नहीं जाना पैसे दे के खरीद ले
okay,
जब तक नीट का एग्जाम नहीं होता सर बोलते बोलते लिख रहा है
this is
उसको लिखने की आदत है बोलते बोलते दो पेपर में पढ़ दिया बात करते करते
so this is your bottom.
नहीं मगर सर्टिफिकेट हम आते ना
Point
सर्टिफिकेट ना बता
bottom
ना
is
जाते
showed on the top
कार शरीफ तेरे को भी कहाँ आया रे
area.
हाँ
Students,
इंटर का 10th का सर्टिफिकेट बता तो कहाँ आया बेटा तेरे को भी कुछ बोले कि ना रेटिंग है बोल के खाली मियां और मंगा और यहाँ से ये वो बोल के बोले
bottom is showed on the top. Any idea? Okay, so this is right view. Right view is showed on the left side. Okay, I'm going to generate a left view. Left view is showed on the right side. Why everything is opposite? This is again top view. Top view is showed on the bottom side. Who is going to answer this? Why in opposite directions? Okay, so this is because we usually use first angle projection. Okay, how many angles of projection we are using? We have 4 quadrants. Okay, out of the 4 quadrants, so in your drawing class you have already learned this. Okay, so we use either first angle projection or third angle projection. Okay, if you are using first angle projection, then this will be the case. Okay, because okay, this is your first quadrant, second quadrant, third quadrant, and fourth quadrant. Is it clear, guys? This is your first quadrant. Okay, 1, 2, 3, and this is 4. Okay. So ISO usually, again, it depends on the companies. We cannot say they all use the first angle only, or they all use second angle only. Okay. So when you are using first angle projection, okay, for example, the object is here and observer is here. Observer is observing from this direction. Okay, let's see. From this direction, observer is observing. Then this object will be projected onto this plane. Okay, and if the observer is observing from top, then we have a plane here, and the top view will be projected onto this plane, because this plane is on the bottom side. So always when observer observes in the first angle projection, then the top view will be on bottom side. Okay, and if the observer is observing from right side, then the plane is on the left side. So that's the reason this will be projected onto this left side. So that's the reason always in front angle projection, first angle projection. Okay, in first angle projection, this is the case. Always front view will be 1. Okay, front view will be, this will be your front view. Okay, and then side view will be on the right side. Left hand side will be on the side view will be on the right side. Right hand side will be on the left side. Okay, vice versa. Okay, and if it is a third angle projection, so we don't use second and fourth angle projections. This is interview question, and why we don't use, they ask you. Okay, we have 4 quadrants, but why are you not using 2 and 4? We are using only 1 and 3. And some companies use first angle projection, some companies use third angle projection. Okay, when for example first angle projection, so because we draw them on flat sheets, so always this plane should be rotated 90 degrees. The horizontal plane should be rotated 90 degrees. In this case, for example, if the observer is observing from here, from top, the top view will be here. So if you rotate it 90 degrees, then that will come here, that is on the bottom side. If you rotate it, okay, and here front view will be here, and the bottom view will be here. If the observer is observing from other side, because of this rotation, you will have the views on different sides. Left hand will be on the right side. Guys, is that clear for you? Because of this planes. Okay, why second quadrant is not used? Because when you rotate it 90 degrees, this should be rotated 90 degrees. When it is rotated 90 degrees, this is going to coincide with this plane. Okay, so that's the reason we don't use second and fourth quadrants. For this also same reason, we only use first and third quadrants. So here the first angle projection is used here. That's the reason the bottom view is on the top, the top view is on the bottom. Okay, vice versa. Okay, coming back to this thing. Okay, coming back to the part. So what else we need in this drawing? So we want the depth of the part. Okay, so either you can get it from here or here. So one view is enough for us. Let's have a look at this top view. Okay, so always the whole is not visible here, so let's switch on the hidden lines. Okay, go here, say hidden lines, and because we have a circle, we have a hole, so let's use center line also. Sometimes it is not projecting. In that case, let's delete this. Sometimes it is not showing axis. In that case, we have to manually create that axis. Okay, this is the hole. Okay, this hole, it will be shown in dotted line. Okay, inside in top view. Okay, so this is the hole, and what information we need from this surface? We want to have length of this. Okay, okay, now we realize that this part is of this much width, and this is the bracket. Okay, now what we need to show radius also. Okay, this is of R7. Okay, always inner radius is shown. Okay, always show inner radius, and then what extra information we need? So thickness is not usually mentioned here. Sometimes we also can show it here. Okay, thickness, so you have to show thickness. Okay, okay. So now we have this information. With this information, we can create this block. Okay, and we have information on this also. Here again, axis is missing. Here, center line. We have axis now. Okay. Okay. So which views are not required here? So in this information, in this view, we have all these dimensions with which it can be manufactured. Okay, and we have dimension for hole also. And in this view, we know how much is the depth of the part and what is the thickness of the part. Okay, in this view, we have already this diameter mentioned here, or else we also can mention the radius also here, either diameter or radius. Okay, based on the requirement. Some drawings, some OEMs, they want diameter to be mentioned, or some drawings they want radius to be mentioned. Okay, let us think, let us assume that here it is diameter. Okay, and when we have primary datum selected here, and we also have three more datums to be selected. Okay, this is first datum, and the second datum, let us consider one plane, you want to control the flatness, okay, for example, parallelism, you can say here okay, because this is a very small part, we can just use only two things, two datums, okay. Either this parallelism is not required. Based on the requirement, if OEM asks you to maintain perfectly parallel with this surface, then you have to say parallelism, and then how much, excuse me, how much parallel it should be with the that value we need to provide, okay. That example I'll give you, but as of now let us maintain only this as B, okay? Let us say this is B. So as this is small part, we are considering only three datums here, okay. What is the theory behind considering the datums, okay. One point, important point, as I mentioned, the surface which is going to be assembled, or which where it should be, the surface roughness should be maintained within some values. That surface will be considered as theoretically flat and theoretically perfect surface, and then we are going to consider that, and all the dimensions will be given from there, so that the dimensions what we are giving will not have any deviation, okay. But as I said, there will be deviations, okay. So there will be deviations. So to we will have plus or minus zero point 0.5, plus or minus 0.02, okay. Based on the requirement of the OEM, we have to give that dimensions, okay. All those things I'll explain you later, okay. So now let us see how this drawing is created, and how the side view, top view is created, okay. And what is repeating in this? See, this information is good if you have this view, okay. So this is not required. Why not required? Because we are not going to show any dimension which is not shown here. So this, in this, we can show, we can cover one dimension here, that is from here to here, 50 mm. What is the width of this? But here already we have shown that, okay. This is the same flange, okay. This is the same flange what we are showing. If it is shown already, then we should not show it again, okay. We'll delete it. Okay, for information sake, let us see this, let us keep this view, and this top view is not at all required, because in bottom view we have already shown all the details, okay. All the dimensions are covered, thickness is covered, radius is covered, so it is okay if this is not shown, okay. So finally, with this three views, we can have all the information. So you can switch on, switch off the frames, okay. You can see here, here we have an option, okay. Once everything is done, all the drawing is completed, then it should be, the frame should be switched off, okay. Boundary symbolic, and any other things which are important to show, I'm just watching, okay. So you can see about this information about these views. Okay, scale is 1:1. Okay, we can also change the scale of this, and after finishing everything, you can lock the view. You have to lock it. Okay, say apply. Okay, now the things are locked, and now the frame is also closed. Okay, frame is also hidden. Now only thing is, one more important thing here is, we need to show one more view, which on the ISO view here. Okay, so you can say go here, say ISO view. Okay, come here, this is ISO view. Go back to part, select the plane. Okay, so this is your ISO view. In ISO view, you can see the part completely. Okay, at an angle of 45 degrees. This is always taken. So isometric view. So let's everything is standard. Okay, everything is standard. Now what we are doing is just assuming, and we are doing it. But if you are working on a project, then they only will guide you how much scale should be given to this one. Okay, ISO view should be 1:3, and the front view should be 1:1 or 1:2. That they are going to guide you. Okay, if it is not fitting in the what is the size of the sheet, we have selected A3. Okay, A3 size. If the size is selected is A4, and if OEM wants everything uh, you need to fit in A4 itself, then you have to check with the scales also. What is the scale you need to use? Okay, so you need to minimize the scale, because here all the name and material details will come here. Okay, I will show you a template where you can see all the details of the parts, division of the part. Okay, when it is designed, by whom it is designed. Okay, on which date, and what is the material used, and what is the manufacturing process. Okay, all the details will be there. Okay, so this is how a part is generated, and a drawing is generated. Okay, so when you start working on different parts, you will come to know all the difficulties what we face in different parts, because as this is a simple part, so you will not have much difficulties in this. But when you go for a difficult parts, then definitely you will be facing some issues. Okay, so manually you have to do it. For example, see, uh, because this is not a licensed version, so you'll be facing some issues with the Catia also. Okay, and sometimes even with the licensed version, you face a lot of issues with the Catia. Okay, because this is a very heavy uh, software. So sometimes to generate the view, it takes a lot of time. For not for simple parts, for but for the big parts, big assemblies. Okay, and sometimes it will not show this axis. Sometimes, okay, in that case we have to generate. Um, that is what interactive. They say interactive um, software. This is okay. So if it is not able to generate, you have to generate it. So we have all the options here. Okay, if axis is not generated, then you can use this and generate the axis. Okay, if something is not generating, then manually you can do it. That is also possible in this one. Okay. So about the theory part, okay, if you cannot understand, not about the seeking theory, about the other theories, what I'm explaining why it should be uh, second and fourth are not used. Okay, all these theory parts are very important. Please remember that, and we will discuss in depth. I'll get some more material on that to explain you and why it is not required. Okay, why first angle and third angle only we need to use. That also we will discuss. And you will have a good idea. You should have that good idea, because to create drawings and all, you need to be very clear on those things. Okay. Okay, and about the, I'll also share the YouTube video which I already shared, but I think it is not reached to you, maybe because of some miscommunication or something. So let us see where it is missing. Then I'll share again. Today you try to install the Catia and start working on these things. Okay, so you can consider this as you can take a picture of this and you can start creating this. This is your input. Okay, you can take this as your input. Okay, take a picture of this if you want. Students, is that clear what I did in 3D model and how I generated a drawing out of it? Any questions on this?
Sir,
Yeah.
sir, where can we get the recorded video, sir, of the previous classes or today's class?
Yes, yes. The videos are already recorded. So Joy is going to provide you the same. Yeah.
Sir?
Joy sir is going to provide you. Okay. The videos are already recorded.
Okay, sir. So can we get it today, sir, then?
Yeah, I'll ask them to provide you. Okay.
So will it be uploaded on Zoom itself or on YouTube?
No, no, Zoom itself.
Okay, sir.
Personally, it will be shared with you. Okay.
Okay, sir.
So you're clear on this, right? How to generate the 3D. Today, any questions on anything is not clear in this? All clear, right? Okay, very good. Then
Sir? Sir?
yeah, please.
Sir, with the app in the laptop, sir, I've got the problem with the license. I've just installed it, but when I'm opening it, it's showing the license and all. It's not opening properly. So what
Yeah,
should
yeah.
we do?
I'll share one link today, video where they are showing clearly how to install it. Okay, so you can with that with the help of that video you can install it. Okay.
Yeah, please send the link, sir. Okay. Thank you, sir.
Guys, if no questions, then we'll stop it here. Okay, is that okay?
Okay, sir.
Okay, sir.
Yeah. So in this only this symbol we need to add here. Okay, that symbol also will add, and the toolbar somewhere it is missing. Again, we have to touch it. There are so many toolbars. Okay, and it is hidden somewhere in this. So you have to do a lot of research on this. See what all symbols, where and all they are available. You can search. Okay, there are so many symbols in this. These are the data. Okay, these are the types of different types of dimensioning methods. Okay, some people they will ask you, for example, instead of using this, if you dimension. See, all these things are manually you can do it here. You want to create a corner, you can create it here by isolating it. I'll show you how to do that. Okay. So mirror, this is mirror. Okay. All these things are explained. Okay. Dimensioning, how to dimension on the points, lines, okay, circles, type of circles. Whatever is available in the sketcher, almost everything will be available in drawing also. Okay, and that how to use here, and we should not modify the drawing. Mostly we have to generate it from 3D only. Okay, that is what expected from a design engineer or the person who is working on Catia V5. We should not modify the drawing, anything, any part here, because this is directly generated or projected from the 3D model. So whatever you do changes in the 3D, that should reflect here directly. So that is what expected. If you are if you want to modify, this also can be modified, but how to modify it? You need to isolate it. Okay, if you see here, you have one option like isolate. So that means breaking. When you say isolate, you are breaking the link with the 3D. So if you once the link is broken, then the 3D is not going to even if you do changes in the 3D, this 2D is not going to update. Okay, so that's the reason we should not isolate it. Even after isolating, we can connect it again, but it is not recommended to isolate the 2D so that we can have connection with the 3D, and always we can update it. That is the easiest way and genuine way we should say. Okay, if something is not some dimensions, they ask some dimensions and it is very difficult for us to get those dimensions. In that case, with prior intimation to the OEM, we are going to modify it. Okay, because in 3D there are some problems, we couldn't able to get it, so that's the reason we are modifying this. Then they say yes, go ahead, then only it is okay to modify the 2D, or else always it is good to project from there. Okay, okay, so for today we'll stop it here. Okay, this will do more clearly. It's actually connected to this. So we have one more option where that and all I'll do and send it to you. Okay, okay. Let's stop it here then. Okay, if no questions, then stop it here. And with the help of that link, please try to install it, and then we will go ahead with the other options, and tomorrow we'll see how other options are used. Okay, and the remaining options, we have so many options in this. So how all these options we will one by one will go through, and I'll show you. Okay, okay, then good night and see you tomorrow. Not tomorrow, day after tomorrow. Okay, okay guys, good night.
Okay, sir.